This lesson will walk you through how to use ramps to refine meshes using stress data from previous structural analysis. This can be useful when trying to get more accurate FEA results in parts where your stress concentrations have already been evaluated, or for comparing a part that you've previously analyzed and then modified in some way. Let's begin by creating a geometry section and importing the same bracket we used in the last follow-along lesson. We'll add our CAD body to our notebook and convert to an implicit. We'll make this a variable and call it implicit. We'll add a new section called Field from Stress Data. We'll use the same CSV file with stress data that we used in our last video. In the Utilities section, under our Fields tab in the upper ribbon, we'll import a scalar point map. Follow the file path and import your CSV file. Again, our units will be in millimeters and our scale will be in pascals. We can isolate this point map and view our results. Now let's convert this point map into a field like we did earlier using a field from point map block. We'll call our point map stress data. And again, use barycentric interpolation and no extrapolation. After creating this stress field, I'll make this field into a variable called stress field. After creating this field, I'll pull a ramp block into our notebook to drive the edge lengths of a mesh. I'll add a section called Refine Mesh based on stress results. From my search bar, I'll add a ramp to my notebook. I'll pull my scalar field in, and I'll set my in-min and in-max at 55 pascals and 5E7 pascals. My out-min will be 2 millimeters, and my out-max will be 0.1 millimeters. I'll give it a geometric continuity. This ramp block will make edge lengths longer where stresses are lower, and much shorter where stresses are highest. I'll make this into a variable and call it edge length ramp. Next, I'll begin to mesh our part. I'll add a mesh from CAD body block and isolating using I see that we've created this mesh. Next, to distribute our triangles more evenly, I'll add a remesh surface block. We'll pull in our mesh, and for our edge length, we'll use the ramp that we created above. We'll choose triangles and let the mesh run. We'll add a volume mesh block as well, since we're setting this up for FEA. And pull in our remeshed surface, as well as our edge length ramp. Finally, we'll add our FE volume mesh, pull in our volume mesh block, and select our geometric order. I'll make this a variable called FE mesh. After our mesh is complete, we can see that the areas of high stress have much shorter edge lengths on their mesh elements than areas with lower stresses. Comparing this to our point map, we see that those areas are around these holes and this larger bearing hole. The same is reflected in our FE mesh, and at this point, we could rerun our structural analysis with our new mesh for more detailed information in the areas of higher stress.